Example 5 asks us to do the exact same things as we did in example 4. The difference is this time I don't have a linear equation. Now we have a cubic since I have an x cubed. So we're going to need Desmos to help us with this. So let me pull up Desmos real quick. Okay. And so let's go side by side here. We're going to type in our function here. So I have g of x equals 2x cubed plus 1. Okay, so we can see what our function is supposed to look like here. And because I have a standard graph here going from -10 to 10 and -10 to 10 on both x and y, I'm going to go ahead and change my graph here to look the same. So first, let me zoom in a little bit. And let's go into settings. My x is already from -10 to 10, but I'm going to change my y to be the same thing. I want everything to be a step of 1. And I don't like these minor grid lines personally, so I'm going to take those away as well. Okay, now if I make this bigger, I can see all of those grid lines. But when I'm on a part of a screen, I can't see those. So let me just kind of make that big for a second. When I'm looking at this, I now need to make a table so I can get some values that I can plot on mine. And remember, when we do this, I'm not changing x1, but I am going to change y1 to what y equals. And here g of x is the same as y. So I'm just going to copy and paste this. And I have a caution sign here. I've got too many variables. I have x1 here and I have x here. So I will change that to an x sub 1. Okay, so now we're ready to go. So one of the biggest questions are, well, what x values do I need to put in? And you just need to look at this graph right here. It's starting at -10, but you can see you have no values of your graph at -10, at -9, at -8. And you keep going, and I have nothing at -3. I don't see anything at -2, but I do finally see a value right here at -1. So that's where I'm going to start my graph. Now I could start it at -2, and so this clearly does not fit on my standard graph here. Okay, so I'll just go ahead and leave it. But I want -1, 0 is right there on my graph. 1 is on my graph. And 2 is going to be the same thing. If I go to 2, that has 17, and so I don't see that on my graph. So it's just these 3 points here that I can really plot. So on here, for part A, graphing g of x, my g of x, and I do my x, y column, we can fit -1, -1 on my graph, 0, 1, and 1, 3. Okay, so those are the points I'm going to plot. Now, if I could fit more than 3, I'd probably want to do more than 3, but that's kind of all I can fit. Now, be careful, because I could technically draw a straight line through it, but I can see in this Desmos, it's not a straight line. And I know it without even using Desmos because it's a cubic, right? So when we plot this, we are going to kind of make it squiggly like we see right here. So it goes here, and then it's going to kind of go straight down, where notice it's not even hitting that -2. And then it will squiggle up, and try your best not to even make it hit that 2, because we know that that's also off of our graph right there. Okay. So now part B wants to know, is this function 1-to-1? That's what we covered at the beginning of the lesson. For it to be a 1-to-1 function, not only does it have to pass the vertical line test, but it also needs to pass the horizontal line test. And no matter where I put a horizontal line, it's only going to intersect the graph once. So Is this graph one-to-one? Yes. Now you can just leave that like that. But if this was my notes, I'd want to know, why is this a yes? And it's a yes because it passes the HLT, the horizontal line test. So part C wants to know, does g of x have an inverse? Well, if it is one-to-one, then yes, it has an inverse. I'm just going to put an arrow. If it is yes, one-to-one, then it is yes, it's going to have an inverse. So now part D, and the reason we made this table right here is if it does, graph the inverse on the same axis. Okay, so my inverse of g of x, I'm going to do this in a different color, obviously. And to be able to find the inverse, all we do is switch our x and y coordinates. So what was my x is now my y. And what was my y is now my x. So plot those. Okay, and that can kind of, again, look like it's going to be a straight line, but it's going to have kind of the same bend that we have right here. So it will go here and then kind of curve and go right there. Now, one thing I didn't do when I did my g of x was label it, but I'm going to go back and label. So my red is my inverse and my blue is my function. Now just make sure that it does have that symmetry that we need for visual purposes. I'm going to put in my line of symmetry. We talked about on the last page that this should have symmetry with respect to the line of y equals x, which is just the linear line with a slope of 1 and a y-intercept at 0, 0. So you're going to go diagonally from corner to corner through the origin. And so this is my line of symmetry. This is y equals x. And so when we have that, you can see that if you were to fold this piece of paper along that dotted line, everything would land on each other. Everything is equal distance. This is 1 unit apart. This is half a unit apart, and that's on that line. So we did the graph and the inverse correctly. And then lastly, we want to be able to find the inverse. Okay. So I'm just going to go ahead and rewrite this real quick. Okay, when I find the inverse, step 1 is to replace your function notation with y. So I have y equals 2x cubed plus 1. Step 2 is to interchange your x and y. Which is exactly what we did right here, right? We switched our x and y's. Step 3 is to solve for y now. So now I want to get this y by itself. So the first thing I need to do is subtract over my 1. Now these are not like terms, so they're going to go side by side. This is x minus 1 equals 2y cubed. I now am still trying to get this y by itself, so I need to isolate the y cubed. So we're going to divide by 2. And there's nothing I can do to that right there, so we'll just leave it like that. So x minus 1 all over 2 equals y cubed. Okay, we've never really solved a y cubed or an x cubed. But what do you think the opposite is of cubing y? Okay, just like the opposite of squaring is square root, the opposite of cubing is the cubic root. So I'm going to take the cubic root of both sides. So here, that cubic root and cube cancel, leaving me just that y. Let me move that down a little bit so I've got some room to write the rest of it. So we'll have the cubic root of x minus 1 all over 2, and that equals y. Now, there are 4 steps to find the inverse. Step 1 is to take your function notation, change it to y. Step 2 is to change your x and y. Step 3 is to get y by itself. Step 4 is to put this in inverse notation. So I started with g of x. The inverse of g of x equals the cubic root of x minus 1 all over 2. Okay. Specifically for my students that are on campus, if you give me this as your final answer, let's say this problem's worth 5 points, you're going to get 4 out of 5 points. You have to make sure you remember to put this in inverse function notation to get full credit on your test. Okay. Now, one thing that's kind of cool, since we already have Desmos put in there, I'm going to go ahead and put this function into Desmos. Okay. I don't know if it does inverse notation. Let's see. Yeah, seems, no, it doesn't like that. It's got that caution sign right there. So let's see if I can still just call it g of x. Okay. We'll just call it g of x, but we do know it's the cubic root. I'm going to come in here and there should be a function for it. Let's see if we can find it. Right here. So the nth root, I'm going to put a 3. If I put in x minus 1 all over 2, you can see there is my function. If I want to take it a step further and put in y equals x, you can see that line of symmetry that we have right there. So that does match what we did here. And so now I have the name of this inverse function.